Bioprinting by John Gemma. So this first slide is what is bioprinting and where did it come from? Now, bioprinting is a printer that has the ability to produce cells and therefore organs. It originated from its predecessor, which is the 3D printer, which obviously only printed plastic products. The 3D printer or the bioprinter is a great advantage in technology and it has a lot of good things going for it that can help out in different situations. Now, how did they start? How did they start this very complicated process of bioprinting? Step one is that they first take a scanning of the patient and they make a digital representation of the person. The purpose behind this is that it takes away a lot of human error and it also gives the printer a better representation of what it's going to be printed. A lot more exact to the organ that it's going to be replicating. Step two is the bioink, which is the ink of this printer, and it's unique to every person. This is because it uses their cells. So it basically piles up these layers of cells and creates tissues and therefore eventually an organ. First, they have to create this bioink, and that's done by cultivating the person's cells, and they can cultivate from skin cells, bone cells, and muscle cells. So, continuing on in how this process is done. First, after they get the bioink, they start printing. So it takes a very long time. So for several hours, the printer works on printing these very thin layers, and it uses a very precise head in order to put down these thin layers. And the final step is that sometimes these cells will fall into place by themselves, just as they're printing. However, sometimes they need some help, and they will use a dissolvable glue that's it's kind of like a scaffolding, and you can see down here at the bottom, it's kind of like a honeycomb shape. So it'll take to that structure, and it'll use that for a foundation, basically. And once it has its structure, it will dissolve away, and it'll just be left with just the tissue and no glue. Why is organ printing important? There's a great shortage of people donating, and there's a large list of people who need heart donations and other organs. So this would obviously take away the middleman of having someone needing to donate their organs. Instead, someone can just print up an organ, and it'll be a lot more exact, and it'll also be a lot less work for a surgeon to have to take it out of someone and put it into someone. Instead, it'll just be printed up, and they can put it into a person. Moving on, what are some uses? So the first and more obvious use is that it can help with birth defects, accidents, aging problems, and diseases. So I think a good example of one of these would be if you took aging problems, for example, and you say someone that has bad knees or needs a hip replacement or a knee replacement, instead of using other products like metal or plastic replicas of a kneecap, they can just print one and make it more exact to the person. And I think that's a good example of aging problems. Accidents, you can say the same thing. If someone damages something in an accident, the same can be said. They can just print one up and use it in the same way. I think another very important but probably less obvious to most people is situations like food and clothing. So because you can print tissue, you can also print food and leather products, and this can be helpful in low food situations where food is running low as far as livestock. They can print it up. Or if you're someone that is interested in animal-free products, not having to kill an animal in order to get food or clothing, this could be a possible solution. And the next slide is some challenges. So though this technology is very promising, there's obviously some problems and some bugs that come along with it, and most of it is in its application of the product. So the first thing is obviously it's very complicated and complex, and it takes a well-trained person to use the bioprinting. Number two is the technology is more or less in its infant stage, which means that it's very expensive. Number three is that genetic information is all the same in the body. All cells have the same DNA, but they have different structures. This means that some cells can be more sensitive than others, and in so it means that um, during the building process, one cell might be more likely to die than other cells. This could be a problem with the body possibly rejecting that organ or just the organ's function in general, if it can even function. Continuing on with challenges, another problem with printing is its capabilities, and the printer can only have a maximum printing of 2 inches thick as of right now. And the reason behind this is because as it layers up these cells, there's no nutrients going to the inner layers and the base structure of the cells. So the inner cells aren't getting nutrients, which means they're dying off. So you have the same situation where it might be rejected or it might not work at all. And pros and cons of this new technology. Personally, I found that there is more pros than cons, but there's still a good amount of cons. So pros, obviously, there's less labor for the surgeon. As said before, it's not like you're doing a transplant where you're taking out of someone, putting it into someone. You already have something printed up, and you only have to go into someone once. You don't have to open up another person in order to get that organ. Another possible thing is decrease in animal testing, and I think this kind of goes hand in hand with animal-free products. So things can be tested without having to use living animals. Again, as stated before, less human error. So there's using the scanning process, you can make a more exact replica, as the next bullet point states. And the last one is less likely to be rejection, which also goes with the replica. If you have a more exact replica and you have something that fits the body perfectly and has the same DNA as the person due to the bio ink, then it's less likely to be rejected. Cons, like stated before, it's in its infant stage, which means there's not a lot of people doing this right now. So if someone were to want to get a transplant, it would be very expensive. So it's probably only affordable to the wealthy. Not known because it's a new technology, but there could be unhealthy emissions going on. But that's something that needs to be learned and documented over time. Ethical concerns. And the last one is liability for organ failures. So this is the case where if someone were to die while using a printed organ, who is to blame? Is it someone that printed the product? Is it the manufacturer of the printer? Or is it the surgeon that put in the product? I don't think this is as big of a con as some of the other ones. I think they can probably work this out and figure it out, but as of right now, it's still a problem. So, an expansion on ethics and why it's a possible con. One problem is safety. So, how safe is this product? It's, again, a very new technology, so no one knows how exact it is and how well it works. Another one is equal treatment options. So, is it ethical if someone with more money has this opportunity open than someone who doesn't? And the last and final one is biological enhancement of one's body. Is it ethical to enhance someone, to give them more muscle or to put in larger bones or should nature just have its course and not use treatments like this? And as a summary, just some main bullet points. So again, it's a very promising technology for printing organs. It can help out a lot of people in a lot of different situations. It's very complex and very expensive, and it still has a lot of bugs in its designs that need to get smoothed out. And as far as the expenses go, and most of these, I think it's just a matter of time and working things out. And the more that people start to get into this industry, the more that expenses will probably come down, and that also the kinks and the bugs will get worked out. And the last slide is just my resources, and that is it. Thank you for listening.